Hi everybody, this is Dr. T. Anthony Santosh, Assistant Professor of Chemistry, St.Joseph's College of Arts and Science, Cuddalore. I am handling physical chemistry and now I would like to discuss some of the topic in the second MSc Chemistry course, reaction kinetics, electrode kinetics and photochemistry. So when we are discussing this topic, I have already discussed in the first presentation some of the topics of photochemistry. And now I would like to discuss the Franck-Condon principle. What is Franck-Condon principle? First, how it is started, and next I would like to explain what are all the principle behind it and the graph involved in it and what are all the things importance like that I will be discussing. So the Franck-Condon principle is named after the scientists' names of James Franck and Edward Condon. It is a rule in spectroscopy and quantum chemistry that explains the intensity of vibronic transitions. Actually, what is vibronic transitions? The vibronic transitions are the simultaneous changes in the electronic and vibrational energy levels of a molecule. How it will happen? It is due to the absorption of or emission of a photon of the appropriate energy. By the absorption or emission of a photon of energy h nu, this vibronic transition, what is vibronic? That is vibrational level of a molecule and electronic level of a molecule that happens. So it is the rule in spectroscopy and quantum chemistry that explains the intensity. Okay, so this principle states that during an electronic transition, a change from one vibrational energy level to another vibrational energy level will be more likely to happen if the two vibrational wave functions overlap more significantly. So this is the main principle. So during an electronic transition, a change from one vibrational level to another vibrational level will happen when there is a overlap more significantly between two vibrational wave functions. This is the main point. So this is the picture which gives us some of the ideas of the excitation. I will be coming again to this picture. So we can see there are two electronic energy levels, E0 and E1, and the excitation happens from one position to other position, from E0 to E1. That excitation happens, and from that de-excitation also given with another down arrow. Okay, that is also given in the picture. I will be coming again to this, and before that I will discuss some of the points involved with Franck-Condon principle. Okay, so Franck-Condon principle describes the intensities of vibronic transitions or the absorption or emission of a photon. I am already explaining that a photon is equal to h nu. Each photon consists of energy h nu. H is Planck's constant and nu is the frequency of radiation. So every photon will be having some amount of the energy. The photons or the energy of the photons will not be fractional. That is also one of the rules. So that may be 1 h nu or 2 h nu or 3 h nu or 5 h nu or 7 h nu, like that. So it will be of whole number. It will not be of fractions like 1.5. There will be no 1.5 or 2.5 or 3 by 5, like that. There will be no fractional photons energy. Okay. It states that when a molecule is undergoing an electronic transition, what kind of electronic transition? Such as ionization, the nuclear configuration of the molecule experiences no significant change. So we should be clear at this point. The nuclear configuration of the molecule experiences no significant change. This is due, in fact, that nuclei are much more massive than electrons, much more massive than electrons. We already know nuclears are known for their the particular or atom or particle, the nuclei are responsible for their weight, and electrons are responsible for their size. Okay, so massive than electrons, and the electronic transition takes place faster than the nuclei can respond. That we should know. Okay, so this is due to, in fact, that nuclei are much more massive than electrons, and the electronic transition takes place faster than the nuclei can respond. When the nucleus realigns itself with the new electronic configuration, the theory states that it must undergo a vibration. Clear? When the nucleus realigns itself with the new electronic configuration, the theory states that it must undergo a vibration. So since electronic transitions are very fast compared with the nuclear motions, vibrational levels are favored when they correspond to a minimal change in the nuclear coordinates. Okay, so these are some of the important points of Franck-Condon principle, and we have some more points there according to the supportive to the principle, Franck-Condon principle. The Franck-Condon principle states that as electrons move very much faster, 10 to the power minus 16 second, actually it is given as 10 to 16 second, it is not 10 to 16, 10 to the power minus 16 seconds than nuclei. That nuclei's transition is 10 to the power minus 13 second. Once again you have to correct it. The nuclei as effectively stationary or static in a particular position during an electronic transition. The nuclear motion are negligible during the time required for an electronic transition. The nuclear motion are negligible during the time required for an electronic transition. And I would like to tell you another thing, that is, according to Franck-Condon principle, during electronic transition, the position of nuclei practically remains unaffected. The transitions are called vertical transition. So the main thing is the position of the nuclei practically remains unaffected, and the transitions are called vertical transitions. Clear? So in such electronic transitions, the geometry of the molecule is unaffected. So the geometry of the molecule is unaffected. So let us see the graph again. So this is the vertical transition, what we are explaining. During electronic transition, the position of the nuclei remains unaffected. The transitions are called vertical transition. In such electronic transition, the geometry of the molecule remains unaffected. Clear? So these are all some of the important points of Franck-Condon principle. Let us move to the next topic. That is importance of solar energy. So it is also related with photochemistry and very much important to the topic. Okay, so solar photons convert naturally into three forms of energy. In what way the solar energy can transform? Well, let us see. Electricity, chemical fuel, and heat. Okay, so these are the three forms of energy, and heat that link seamlessly with the existing energy chain, that we should understand. So we are getting energy from the sun. That is what solar energy, simply speaking. The solar energy can be used in several ways, because the fossil fuels of petroleum and other things are decreasing in quantity, as per the scientists says. Okay, despite the enormous energy flux supplied by the sun, the three conversion routes supply only a tiny fraction of our current and future energy needs. So solar electricity at between 5 and 10 times the cost of electricity from fossil fuels supplies just 0.015% of the world's electricity demand. Okay, so because for the from the fossil for the conversion and the progress of the fossil fuels, we have to work a lot. That is what we are doing now. Okay, so for converting the fossil fuel into the proper form, in the reusable form, we are spending several much amount of energy. But nowadays from solar electricity, it is much cheaper. But initially we have to spend money to produce that solar energy. Okay, so next, the solar energy, solar fuel in the form of biomass accounts for approximately 11% of world fuel use. But the majority of that is harvested unsustainably. So this is also an important point. The solar heat provides 0.3% of the energy used for heating space and water. It is anticipated that by the year 2030, the world demand for electricity will double and the demands for fuel and heat will increase by 60%. So ultimately for meeting out that 60% need, we have to go for some other energy purpose, and there the solar energy will be a very important alteration from the energy of fossil fuels. The utilization gap between solar energy's potential and our use of it can be overcome by raising the efficiency of the conversion processes, which are all well below their theoretical limits. Okay, so this is what we are saying. Despite the abundance and versatility of solar energy, we use very little of it to directly power human activities. Solar electricity accounts for a minuscule 0.015% of world electricity production and solar heat for 0.3%, which we have seen of global heating of space and water. Biomass produced by natural photosynthesis is by far the largest use of solar energy. Its combustion or gasification accounts for about 11% of human energy needs. Okay, so these are all important points and of solar energy. Now I would like to explain you how there are different generation of solar cells that is present global. The three generations of solar cells. First generation cells are based on expensive silicon wafers and make up 85% of the current commercial market. Second generation cells are made up of silicon, nanocrystalline silicon, cadmium telluride, or copper indium selenide. The materials are less expensive, but research is needed to raise the cell's efficiency to the less shown if the cost of deliver power. The third generation cells are research goal, a dramatic increase in the efficiency that maintains the cost advantage of second generation material. So these are the difference between the first generation cells, second generation cells, and third generation cells. So next I would like to give you how the process of solar energy is used. So we could see how in this animated picture, it is not animation but a picture, it clearly shows of how a chemical reaction can give us energy, and from the sun how can harvest the solar energy to for our the utilization. So the solar collectors giving us heat and the absorbers using heat, then that is converted into the chemical reaction or solar fuel, and that solar fuel next is transferred to power generation. Chemical engineering and other things are used for the utilization of the make it possible for our people. Or in other way, the chemical reactants, by using chemical reactions, will give the energy to the solar fuel, and that from that we can get the utilization energy. So this is how the process of solar harvesting happens. Okay, we have seen Franck-Condon principle at first, and the importance of solar energy, and the 3 generation cells of solar cells, and how the process happening beautifully in this picture. Thank you.